Welcome again to another Prism video. Today I'm showing you a sneak peek about automation. This is going to be a quick video to where I'm going to show you how to start a session by just choosing the target. Prism will even take care of figuring out which target is westward most and image that first and segregate the targets like that. So he images the ones that set first and so on and so forth. So everything is set up already, and I'm going to show you how to set up all this automation in a different video that discusses all the tabs: focusing, dome and shelter, image grab options, telescope, flats, and so on and so forth. So for this one, I'm going to choose M45, which is just rising above 30 degrees above the horizon, then NGC 891, and then M31, which is the highest. Typically, a software will go to M45 first, and then image NGC 891, then M31. Prism is smart. It's very intelligent. It'll go to M31 first, because M31 is further west first. So we'll turn on our ASCOM digilogger switch, and we'll launch the automation. As you can see, Prism just turned on the first option, which is the focuser. It's the third from the top, Optech focuser. So that's on, and I have a 30-second delay to allow for the next one to be turned on. You always want to stagger turning on the switches. Here's the IR camera that's inside the observatory to show you what is happening. Next will be the 814 camera, which is just got turned on, and 5 seconds later will be the HDX 110, which just got turned on as well. So Prism has a timer, and it waits for 30 seconds for everything to stabilize, what needs to connect, and what needs to be set up, and so on. It's always good to have that timer in there. Now we connect the equipment: focuser first, dome, filter wheel, telescope, and everything is connected. To make things clear, let's just minimize all the windows. What's great about Prism is that the one interface can be moved around. The sky chart made smaller or bigger. I like to have it full view like this because I really like the sky chart. It's beautiful, it's detailed, and it can contain as much information as you want. We can see from the webcam that the dome is opening. And by the way, the webcam refreshes every 5 seconds. The slit is completely open. And now we slew to our first target. Remember that I put M45 as the first target to be imaged. I asked Prism to go to a given coordinate and solve and sync. This is really good for mounts that need to be synced first. So what we'll do is we'll slew to that point, and then we will do a blind solve. So we'll take a 20-second exposure and blind solve it. Here's a 20-second exposure with the luminance filter. Plate solving was very fast, and we're on our way to M31. This is how Prism segregates the targets. Since M31 is furthest west, it images M31 first. The dome is is following the scope, and it looks like the scope is at the destination already. So the dome will rotate to match. We asked Prism to pick a given magnitude star to focus with the luminance filter. So once you get to the target, it will choose a star to focus on in subframe. As you can see, it also checks the weather conditions every 1 minute. Focusing within 17 to 2300 steps, and start position has been found. And there it is. Prism will move the focuser to 1700 encoder step position and starts the increments, 50 increments at a time to focus. It takes an image before it starts focus, and then when it focuses and finds the best focus position, it takes another image, then it compares before and after. What it'll do is it'll increment the focuser steps 50 encoder steps at a time for 13 iterations. This way, we're sure it will cross the focus point and find the best focus position possible. Focus run is completed. Focusing has been found at encoder step 2018, and HDF after focusing is 4.76 and before was 5.07, which means it's an improvement. Now we slew to M31 and we take an exposure. First we'll plate solve and center the target. So the plate solve exposures are 20 seconds long to ensure we get enough stars for plate solving to be successful. There's the core of M31. It's a little bit off center, but Prism will plate solve and shift it. There's 3 arc minutes off in declination and 1 arc minute off in RA, so the shift will happen. That's the load star frame, so now we pick a star automatically and guiding is started. There is M31. Dead center. Now Prism will slew to NGC 891 since it's the second candidate that is further west. Now bear in mind, this setup is in New Mexico and I'm in Arizona. So I'm accessing this setup remotely through AnyDesk software or TeamViewer. And all I have to do is launch the automation by choosing what targets to image. And Prism will handle the rest for me. There it is, NGC 891, my favorite Edge-on galaxy. And now we'll slew to the last target, which is M45. Since we're slewing so far, we've requested that Prism autofocuses again. This is very powerful for people with moving mirrors. I've only done this for the sake of demonstration. I have a Ritchie Chrétien telescope which has a fixed primary mirror, so less of a chance of mirror flop, if you would. The primary mirror is cemented in. I have an Optec focuser that is extremely rigid. So if you have an SCT, for example, and you don't want to chance the mirror flopping around, you can tell Prism to focus if you slew more than, say, 20 degrees, and it'll autofocus for you. This is especially handy for flipping the meridian. We found a star, plate solving is successful, and the star is dead center of the subframe. And we'll do the same thing again. Take a range of focus, 50 encoder step increments, 13 times to find the best focus possible. And do not be afraid, this does not happen this often during the night. You can tell it to focus every hour of time, if you would, and or if you cross a given threshold of distance, like I said, 20, 30 degrees, that's up to you. The beauty behind it is you can automate the entire night while keeping your images at their sharpest possible. Focus has been found. Take one more exposure to check before and after, and again we have an improvement. Now we slew to M45, plate solvent center. There is M45. You can even see the nebulosity in the background. We start the guider, take a 5-second exposure with the lodestar, and subframe and start guiding. This is also a 60-second exposure of M45. Since we have an AAG Cloud Watcher installed, Prism checks it every 1 minute to make sure it is still clear. That's a beautiful shot of M45 in the background of 60 seconds for the sake of this demonstration. Now, Prism will, since this is the end of the observation, it gives us a recap of what happened, the scene, elongation, and so on, and it's parking the mount what I told it to park, as you can see in the webcam. It'll also park the dome what I told it, which is north, and then close the slit. Now the slit is closing, the dome is parked north. Before Prism turns off the power to your camera, it ensures that it has warmed up first. As you can see, it's waiting for it to reach negative 0.7 Celsius before it turns off power to it. It's smart enough to protect your equipment as well. Here we go. Disconnect the focuser first, and then the camera, then the mount. The camera's off and the mount is lost. Hope you enjoyed it. See you on the next one.